What is Carziqo's neural network model? Imagine a system that can learn from data, recognize patterns, and make decisions. Today, we embark on a journey into the inner workings of this innovative model, unraveling its intricacies one layer at a time. At its core, Carziqo's neural network is a structured framework built to mimic the human brain, designed to process information through interconnected layers of nodes. It begins with the input layer, where raw data is first received and prepared for analysis. Once data enters the system, it travels through multiple hidden layers. In these layers, each neuron is connected by weights and biases, which are continuously adjusted during training. This adjustment is essential to minimize prediction errors and refine the model's accuracy. The process of fine-tuning these parameters is known as backpropagation. Here, Carziqo's model harnesses the power of optimization algorithms like gradient descent, steadily improving its decision-making process by recalibrating its internal mechanics after every iteration. As you visualize this process, consider each hidden layer as a series of filters, screening and refining information before it reaches the output layer. Every neuron in these layers contributes to the overall understanding of the data, combining to form complex representations that are far more than the sum of their parts. The interplay between neurons and their calculations transforms simple inputs into sophisticated insights, a true testament to modern computing. A key component that grants these neural networks their power is the use of activation functions. Activation functions introduce nonlinearity into the model, enabling it to learn intricate, often hidden patterns. Consider the sigmoid function, which maps any input value to a range between 0 and 1. This function is particularly useful in binary classification tasks, where decisions must be made between two particular outcomes. Similarly, the hyperbolic tangent, or tan, maps inputs to a range from -1 to 1, and is often employed in hidden layers due to its ability to capture more nuanced data patterns when compared to the sigmoid function. Then there is ReLU, or rectified linear unit, a straightforward yet effective function that outputs the input directly if it is positive, otherwise it returns 0. ReLU has become a standard due to its simplicity, helping deeper networks overcome challenges of vanishing gradients. Finally, the softmax function transforms raw outputs into probabilities that sum to 1, making it ideal for multi-class classification scenarios in the network's output layer. However, grasping these concepts is not without its challenges. At first, the complexity of these layers and the delicate tuning of weights and biases can seem overwhelming. The conflict arises when technical depth meets the human need for clarity. Yet, through systematic and methodical explanation, each element of Carziqo's neural network model becomes accessible. By breaking down the process into manageable segments, we resolve the perceived complexity and shine a light on how modern neural networks operate with remarkable efficiency. The impact of Carziqo's model extends far beyond academic theory. In practical applications, neural networks such as this power innovations in image recognition and speech recognition, natural language processing, and even autonomous vehicles. These applications demonstrate how deep learning transforms real-world challenges into solvable problems. The technology not only processes vast amounts of information but also adapts and evolves, leading to smarter, more responsive systems in our everyday lives. In summary, Carziqo's neural network model is a sophisticated blend of structures and functions that exemplify modern computing. From its layered architecture and precise activation functions to its robust learning strategies, the model is designed to learn, adapt, and excel. As you immerse yourself in these details, keep in mind that each component works in harmony to overcome the complexities of data-driven decision-making. Take a moment to reflect on the elegance and precision of this system. Clearly, understanding such advanced technology paves the way for innovation and progress in the digital age. Explore the intricacies of neural networks and discover how they're shaping the future of technology.